Hey guys, this is the last topic of the year, statistics. That's interesting. I'll delete that. Yeah, we're going to talk about scatter plots first thing. So you have this girl, Luciana. She's starting a 2-week social media campaign to attract new subscribers to Blast On, a music website for teens. She has the following data from her last campaign to help plan her strategy. Based on this data, what should be Luciana's strategy for the new campaign? All right, so I'm going to zoom in on this little chart here. We can see that she has the number of social media posts per day that she does on whatever social media app she uses. And then how many new subscribers she gets, basically based on that, right? So if she does 1, right, she gets 40. If she does 2, she gets 44, and so on and so on and so on. So we can see that as the number of social media posts per day goes up, so do her new subscribers. They get to 5 per day, and then 6 per day, and then we actually start seeing between 5 and 6, we actually see a decrease, right? So it trends down after 5 or 6, right? So her highest day that she had was 5, when she got 120, but then the next day when she went up to 6, it actually dropped down to 104, right? So looks like the sweet spot is 5 posts per day, right? That gets her the most new subscribers. So what should Luciana's strategy be for the new campaign? Well, pretty simple, just based on the data, right? Her strategy, is that right? Strategy should be to post 5 times per day. It can be as simple as that. Okay. So just based on the data that she gets, this is kind of what it's telling her to do, right? So statistics can be very useful in a real world sense, right? Yeah, because people use statistics all the time to predict trends, and basically to tell the future. Anyway, constructing a scatter plot. Luciana, same girl, analyzes the data collected to determine how long after posting a new blog post her new homepage received its maximum number of views. Her data are presented in the table. I know it sounds weird to say her data are, and you think, well, her data is presented, that should be it. But the thing about data is it represents a large number of points, so it is technically plural, right? So you'd be like, her points are, yeah, the amount of information is, well, amount is singular. It's weird. It's plural, right? English is weird. So her data are presented in the table. So we have blog post 1, 2, 3, up to 7, and then 2 hours after posting, she got 350 new views. 6 hours after posting, 50. 1 after posting here, she got 500. So it's just got some data on kind of the number of blog posts and kind of how often after, right? So we can see that if the biggest jump we had was 1 hour after, right? She got 500. So it's basically the new hotness, right? Somebody sees a new blog post, they're all going to get updated, and then boom, a lot of people are going to see it, right? Some people will see it later in the day, but it's less, right, than that initial kind of burst of people after that first hour. So what we're going to do is we're just going to graph this data, right? We have 7 data points, and we're just going to use this as our X value and this as our Y value, right? So we zoom in a bit right here, and we have our table, or sorry, we have our graph right here. Like I said, we're going to use time as our X value and number of views as our Y value. So the first blog post, our first data point, is 2 hours and 350 new views. So over 2 and up to 350. So right there. Okay. So check that down so we know we've done it. 650, so over 6 up to 50 is right there. 1 is 500, so over here, and then right here. 3 is 200, so over 3 up to 200, so right there. 4 is 150, so 4, 150 right there. 7 is 25, so right there. And then 3 is 250, over 3 up to 250. Oh, did I do 2 3s? I did, yeah. Okay. So yeah, you can see that the data varies day to day, right? But what is the question I'm supposed to be asking here? Shoot. This is example number 1, construct a scatter plot. How can she determine whether there is a relationship between the time after posting and the number of new views? Well, what we can see is that as the time after she posts increases, the number of views she gets decreases. So that is the general trend line. That's the general relationship, right? So it is the relationship decreases, right? The relationship between hours versus new views is decreasing. That's not a period, shouldn't be, is decreasing, right? So as the time increases, right, the number of views decreases. So we'll say time increases, views decrease, right? Because over time, the number is going down, right? If you were to draw a line that represented this, your line would go down, it would have a negative slope. So that's what I mean by decreasing. Okay. Okay. Interpret a scatter plot. Rochelle asked 10 of her friends how many hours of sleep they got the night before a math test, and then matched that data with their scores. She plotted the data in the graph. Did students who slept more get higher test scores? Well, we see that we have this kind of cluster of data here, right? Okay, so that represents a cluster, and let's see, a cluster, I think, how do they describe it in the book? It's just a grouping, right? A group of points that lie close together. So we'll kind of define these terms. So that's a cluster. Okay. We have this gap. So a gap, let's see, how did I put in the book? An area that contains no data, right? An area of the graph that contains no data. And the last one here, outlier. Okay, an outlier is the data point is set off from the other data points. So a data point that is set off from the other data points. Okay. So yeah, clusters, when you have your kind of group them together, gaps are areas that have no data, and then an outlier is kind of one that doesn't really make sense, right? It's off from the main set of data. So did the students who slept more get higher test scores? Well, we've got, let's see, this kid who slept 5 hours got a 70, and we have this kid who slept 9 hours got like close to 100, right? Or got to 100. So in general, you can see that our trend line is increasing, right? It's a positive trend line. So the more you sleep, the better you do on this test. There is one student, however, that slept 10 hours, but got a 40%. So sometimes the data, there are obviously people who don't fit the data, who don't fit the mold, or who don't fit the prediction, right? So yeah, those are called outliers. So did students who slept more get higher test scores? Yes. In general, students who slept more got higher test scores. Right. So again, you could use this data to predict something. You could use this data to predict. Well, if you sleep 9 hours, right? Let's see. Actually, that's 10 hours. My bad. They're both on 10 hours, right? That's not super useful. But the more you sleep, like if you sleep 9 hours, the prediction is you're going to make about a 90%, or like maybe like a 90. Shoot, where is that? It's like a 96 or 97, right? So the more you sleep, the higher your test score, right? That's the prediction that you can pull out from this. That's how you interpret this. That's how you get meaning out of this. Right? Construct and interpret a scatter plot. Avery is the middle school basketball statistician. I bet she's super popular. She tracks the number of minutes a player plays and the number of fouls the player makes. Her data are shown in the scatter plot. That always sounds weird to me. Her data are shown. Is there an association between the number of minutes played and the number of fouls made? Well, let's kind of compare this to our other graphs, right? In this graph, we had a generally positive trend, right? Your slope was going up. In this one, we had a generally negative trend, right? Where your data was going down, okay? In this one, it's hard to draw a line that fits this data, right? It's kind of like you could, yeah, right. There's nothing. There's no general line like that indicates whether there's any relationship between these two things, right? So if you see something like this where it's kind of all scattered all over the place and it doesn't make sense, well, that just means there is no association. So you'd say there is no. If I could write no association. You can also say there's no relationship. Between, let's see, what is it? Number of minutes played and the number of fouls made. Between the number of minutes played versus the number of fouls made. Because it's like all over the place, right? Doesn't make sense. So when it doesn't make sense like that, there's no association, right? We call this a positive association, and we call this a negative association. There you go, guys. That's your intro to statistics.